So in this video, we are going to learn how to figure out oxidation numbers for elements in compounds. So what an oxidation number is it's a number assigned to each atom. It's like a charge. It can be a charge, but it doesn't have to be. And that number represents the number of electrons that this element has control over. If it's given away, if it's sharing electrons, it's going to be positive. If it's taking extra electrons, it's going to be negative. So here are the rules for determining oxidation numbers. Elemental atoms, which are not bonded to anything else, have an oxidation number of 0. And this includes anything that's all by itself, also things that are all alone, which are diatomic, like O2 and H2. Those also have an oxidation number of 0. Hydrogen is always +1, unless it is with a hydride, with a metal. But this is really rare. We're not going to see this. So for us, hydrogen is always going to be +1. Oxygen is always going to be -2, unless it is with a peroxide, which is 2 oxygens together. But that is also rare. We're not going to see that either. Halogens are typically -1, usually, unless they are with oxygen. And this actually happens a lot. So we are going to see this pretty often. So halogens are not going to be -1. They're going to change a lot. If it is a neutral compound, then all the numbers have to add up to 0. And if it is an ionic, a polyatomic ion, then all the oxidation numbers are going to add up to that charge. So elements with numbers that change a lot include transition metals, and those are, remember, the D block, the ones in the middle of the periodic table. For main group metals, and those are the ones that are not in the D block, their charge is equal to their oxidation number. So for example, sodium is +1. That means that sodium has an oxidation number of +1. Nonmetals that change a lot include sulfur, carbon, nitrogen, and phosphorus. And you'll notice that all of these elements are really close to each other on the periodic table. So we're going to figure out the oxidation number. I'll do some examples, and then you guys can work some problems in the packet. So oxygen has a rule. Oxygen is -2. So we're going to use that rule and use oxygen to figure out the oxidation number of sulfur. So oxygen is -2. There are 3 oxygens, so the total is -6. So the total for all the sulfurs has to be +6, which means that each sulfur, because there are 2 of them, each sulfur has to have an oxidation number of +3, and that's going to go in this spot here. So sulfur is +3. Okay, next let's do P2O5. Again, we know oxygen, and it's -2. And then we're going to use oxygen, which adds up to -10, to figure out what the total is for phosphorus. It's +10, so then each phosphorus has to be +5. This each atom number, that's what the oxidation number of phosphorus is. Okay, NO3 is a nitrate group, so it has an overall charge of -1, so all the numbers have to add up to -1. Oxygen is -2, they add up to -6. So because of the negative charge, the -1 charge, the total here has to add up to -1. So the total from nitrogen is going to be +5. And because there is just one nitrogen, its number is going to be 5. So next, I want you to pause the video and go through and try to figure out what the oxidation number of chlorine is in each of these compounds, and then start it back up and see how you did. Okay, just a couple things to note. Chlorine, because it's by itself, is always going to be 0. ClO3 has an overall charge of -1, so we have to use that in our totals to figure out the oxidation number of chlorine, which is +5. And then same thing over here, chlorine's going to be +7. And in this case, the overall charge is 0, so we're going to use oxygen to figure out that the oxidation number of chlorine in this case is going to be +1. So notice chlorine can really change a lot depending on how many oxygens that it is with. So again, for chromium, pause the video, go through and figure out the numbers for each of these compounds, and then start it back up and see how you did. So just a couple of things to note. So this one is very similar to what we did before. This is probably our most complicated case, and this actually happens a lot with chromium. So we know oxygen, it's -2, it totals to -4. We know hydrogen, it's +1, it totals to +2. So therefore, in order to add up to 0, the total here has got to be +2. And because there are 2 chromiums, each chromium has to be a +1. So +1 is the oxidation number of chromium here. This one's a little bit different. We actually have to use old stuff that we did a long time ago. Sulfate adds up to -2. So therefore, chromium has to be a +2 here. And again, remember for metals, the charge is the oxidation number.